Do you know how to graph sinusoidal functions? Hi, welcome back. Today we'll learn how to graph sine of theta and cosine of theta. We'll also explore how these graphs can change under possible transformations of vertical or horizontal stretch, phase shift, or any reflection. At the end of the video, same as always, I will give you an example to try on your own. Now with no further ado, let's get us started. I'm going to start by graphing sine of theta. And for that, I'm going to use this unit circle where the radius equals 1. We learned about the unit circle previously. The link to that video is in the description. Be sure to check that out. On this unit circle, I have marked 4 key points or 4 important angles. The first one is at 0, and then I move counterclockwise, so that gives me positive angles. The next angle is pi over 2, next pi, 3 pi over 2, and all the way around it gives me the angle of 2 pi. So there are 5 angles, 0, pi over 2 pi, 3 pi over 2, and 2 pi. With these 5 angles, I'm going to be able to graph sine of theta. That easy. I want to keep things really simple. So let's show xy axis. The horizontal axis represents theta, and the vertical axis represents f of theta. Since we're going to have one full revolution from 0 to 2 pi, the maximum theta I'm going to use is 2 pi. So let's mark here and let's call it 2 pi. And the other angles, I can also show them on the x-axis or on the horizontal axis. This is going to be halfway between start and end. That's pi. And we have pi over 2 and also 3 pi over 2. Each interval is pi over 2. We call it x-scale. X-scale in this case is pi over 2. Now I'm going to find sine for each of these angles. Starting from 0, I know y equals 0, so sine of theta is 0. That's the first point. The second point happens at pi over 2, where sine is its maximum value of positive 1. So that's going to be up here. And then at pi, sine is 0, going down to 0. So far, the graph looks like this if I connect them with a smooth line. Then, at 3 pi over 2, y value is negative 1, therefore sine is negative 1. And lastly, at 2 pi, sine is 0. I'll connect these new 3 points. This is one cycle of sine of theta. Why do I call it one cycle? If I keep going after 2 pi to the next angle, let's say 2 pi plus pi over 2, sine of theta is going to be 1 again. So that goes up to 1. And then going to the next angle, that goes down to 0. Even if I go in the negative direction, meaning from 0, I go to negative pi over 2, the sine of angle is going to be negative 1. So at negative pi over 2, sine is negative 1. And then you can see that it's going to continue the same pattern in the negative side. So this cycle that I showed with the solid red, that keeps repeating. That's one complete cycle. And the length of it in the horizontal axis is equal to 1 period. And we showed with p, which in this case equals 2 pi. And this 1 period is divided into 4 equal intervals. These are called quarter periods, and each of them is defined by the x-scale, which is pi over 2. Therefore, x-scale is basically 1 period divided by 4. We're going to use that in future. The other important feature of this function and the graph of it is the amplitude of it. The amplitude is the distance between the midline, which in this case is y equals 0, to the max or to the mean. It's a distance, so it's always positive. And we showed with amp, and it equals 1. So you can also use midline to the minimum, same thing. The distance is still 1. Now let's see how the graph of cosine of theta looks like. Again, I'm going to use the unit circle where radius equals 1. I'm going to use the same angle, 0 pi over 2 pi, 3 pi over 2, and 2 pi. And here is the horizontal and vertical axis. And I start by showing 0 and 2 pi, then pi in the middle, pi over 2, and 3 pi over 2. At 0, x equals 1, therefore cosine equals 1. So it starts with 1, and then moving in the positive direction at pi over 2, cosine is 0. So that's the second point. At pi, x is -1, then cosine is -1. That means down here we got the third point. At 3 pi over 2, cosine is 0 because x is 0, so it goes to 0. And finally at 2 pi, cosine is back to 1. So this point. Now we have 1, 2, 3, 4, 5 points. And connecting them with a smooth line, that gives me this graph. Again, if I continue going from 2 pi to the next angle, it gives me another 0. And then after that, we go down to -1. And apparently there is also a cycle here that is repeating. But this cycle, at 0, it starts with 1. While for sine of theta, it starts with a 0 in the beginning. It's just like there is a shift between the two graphs. Because if I have another cycle on the left side and the continuation on the right, now imagine that I push or shift this graph with pi over 2 towards right. Then this point will be here. And the graph is going to look like sine of theta again. That's called a phase shift between the two functions. But in terms of amplitude, again, it's 1. The distance between the midline and the max or the mean. Max and mean are 1 and -1 respectively. X's scale is again pi over 2, which is 1 period divided by 4, and that's equal to pi over 2. And as you can see, again, length of 1 period is 2 pi. Now we know how to graph sine and cosine function. Let's just start graphing more advanced functions where transformations have been applied. The generic form of a transform function is shown here, a times f of b times x minus h plus k, where a, b, h, and k are called the transformation parameters, where a and b are the vertical and horizontal stretch parameters respectively. H and k are called the horizontal and vertical shift parameters respectively. In the context of sinusoidal functions, h is called phase shift. Let's see how it works, and to do that I'm gonna show you two examples. The first example, y equals 3 sine of x over 2 minus pi over 12 plus 1. First step, I'm going to rewrite it in the same format of the generic form. So I need to factor out 1 over 2 times x minus pi over 6 plus 1. A is 3, b is 1 over 2, h is pi over 6, and k equals 1. Each of these parameters helps me to find different features of the graph. For example, a equals 3, it helps me to find the amplitude, where amplitude is the absolute value of a and it equals 3. That means the maximum value is now at 3 and minimum is at -3. Previously max and mean were 1 and -1, now it's multiplied by 3, so the new max value is 3 and the new minimum value is at -3. Next, the b value will help me to find the period because it will make horizontal stretch by factor 2, and p is equal to 2 pi over absolute value of b, which equals 2 pi over 1 over 2 equals 4 pi. So the length of one period is 4 pi. Next, I can check the phase shift of pi over 6, which will shift the graph pi over 6 units towards right. And lastly, the k value equals 1 will shift the graph 1 unit up, that means the midline and the entire graph will go up 1 unit. Therefore, the midline is now going to be at y equals 1. Maximum value will go up 1 unit, and it's going to be 4. And minimum value will also go up 1 unit. Now it's going to be at -2. Now we have everything that we need to graph the functions. One more thing, maybe we also can take advantage of the period to find the x-scale, where x-scale is p/4. That's going to be pi. Okay, now let's show x and y axes. I start by showing one period from 0 to 4 pi. The x-scale is pi, so I have 4 intervals: pi, 2 pi, 3 pi, and lastly 4 pi. There are 4 equal intervals. The midline is now at 1. So let's say this line represents the midline. Maximum value at 4. This is y equals 4. And the minimum value at y equals -2. So the graph is going to be oscillating between these two dashed lines around the midline. We know that sine function starts at 0 on the midline. Let's graph the function without a phase shift. Once we know how it looks like without a phase shift, then we shift the entire thing pi/6 towards right. So that's the plan. So it starts on the midline. In the second key point, it goes up to max, and then goes down to midline again, then goes down to minimum, up to the midline again. Now connect these with a dash line. That gives me the graph without any phase shift. But we know that there is a phase shift of pi/6 towards right. So I need to shift each of these points pi/6 to the right. Like this point in the beginning will move to pi/6. This is pi/6. Pi will shift to 7 pi/6. When you add pi/6 to pi, it becomes 7 pi/6. So this is going to be the maximum at 7 pi/6. And then 2 pi plus pi/6, that's going to be at the next point, which is 13 pi/6. So that gives me the point on the midline. 3 pi plus pi/6, that equals 19 pi/6. That's where the minimum is. The last point, 4 pi plus pi/6 equals 25 pi/6, and that's where the graph is on the midline. Connecting these points with a solid line will give me the final graph. But that's actually one cycle of the graph. If you want to continue it from either of sides, that's also possible. Now let's check out another example. In this example, the base function is cosine of theta, or cosine of x in this case. Function is -2 times cosine of 2x plus pi/2 plus 1. So I'm going to rewrite it as -2 times cosine of 2 times x plus pi/4 plus 1. So now I can see that a equals -2. Therefore, the new amplitude equals +2, which means the maximum value is now at 2 and the minimum value is now at -2. And since a is negative, there's going to be a reflection in the x-axis. Next, we can see that b value equals 2, Therefore, the new period has a length of 2 pi over absolute value of b, which equals to pi. So the length of one period is pi, then x scale equals p over 4, which equals pi over 4. Next, h value, or the phase shift, is negative pi over 4, which means the entire graph needs to be shifted to the left pi over 4 units. And lastly, k equals positive 1, which means again we shift the graph 1 unit up. Therefore, the midline is now at y equals 1. Also, the new maximum value will shift up to 2 plus 1, that's a 3, and minimum value will be at negative 2 plus 1, that's the negative 1. Now let's just start showing this information on the xy axis. First thing, I will show length of one period, which is from 0 to pi. So the 0 all the way to pi with the x scale of pi over 4. So if halfway is pi over 2, then the first point after 0 is pi over 4, next pi over 2, and then 3 pi over 4. So now I got the 5 key points that I need to find the value of function at each of these points. The midline is at y equals 1, so let's show y equals 1. Maximum is at 3, and minimum is at negative 1. So the graph of function is going to be oscillating between these two dashed lines around this midline. Same as before, first we graph the function without any phase shift, then we will shift the entire graph pi over 4 to the left. We know that the graph of cosine of x starts with the maximum value at 1, but now because there's a reflection in the x-axis, it should be reflected and it starts from minimum. So at the first key point, meaning at 0, it starts from the minimum value. Then it goes to the midline at the second key point. Next goes to the maximum at pi over 2. Then goes down to the midline. And finally goes down to the minimum at the end of the cycle. So if I connect these points with dashed lines, I'm going to get this graph. But again, this is not the final graph because it doesn't have any phase shift yet. We need to shift everything to the left with pi over 4 units. So this point in the beginning will go to negative pi over 4, and everything else will also go to left with pi over 4. That means the endpoint will be here. Now connect these points with solid line to find the sketch of the final graph, which looks like this. This is one cycle, has a length of pi. If you're asked to sketch one cycle, that's good enough. If you're asked to sketch more, you can keep continuing with more cycles towards left or right. Both directions are okay, and you can do it. All right, now it's your turn. Which of the following graphs represents the function y equals negative sine pi over 6 minus x plus 1? And there are 4 answers shown here, A, B, C, D. Use the transformation parameters to find the amplitude, period, phase shift, and the shifts to up or down to find the answer of this question. And leave your answers in the comment section. Thanks for watching. I hope you now feel confident graphing sine and cosine of theta and understanding how transformations can affect their graphs. Don't forget to try the challenge question and leave your answers in the comment section. I will check them out. And if you enjoyed this video, please give it a thumbs up and subscribe for more math contents. Until the next video, keep solving those math questions.